All right, it says practice 2. This is our first practice by ourselves, I guess. This one says a box of billiards contains 15 balls, number 1 through 15. If you don't know what billiards are, sorry, I'm pulling up a picture for you. If you've ever played pool, that game of pool where you have the stick and you shoot the balls into the pockets on the sides, that's billiards. That's what billiards is. So they're saying that it has 1 through 15, which is true. If you count here, we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 balls. They're not counting the cue, the white ball. We want to find the probability of getting a 9 and then getting a 3. So remember, there's 2 different ways that we can do this. First, let's do the sample space way. First, let's do sample space. So if I'm picking out cue balls, we said that we have numbers 1 through 15. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's all the first ball that I can draw. I'm wanting to draw a 9 and then a 3, and it says I return it. If I return my ball back into my box, is that independent or dependent? If the ball goes back into the box, if the ball goes back inside the box, is the total number going to change? No. My total number does not change because I put that ball back. I replaced it. So this is an independent event. An independent event. The total number does not change on the bottom. The total number is not going to change on the bottom. So that means I have 1 through 15. The blue would be my first ball. And then my second ball, I would have to do 1 to 1, 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6, 1 to 7, 1 to 8. Do you guys see where I'm going with this? These are all going just to the 1. This is all just to the 1. And then I would have to do all those numbers again from the 2. This is probably not a good question to do as a sample space because it's a lot. It's a lot. If I draw out all those options, if I draw that tree diagram like we saw with the dice. So we're going to erase this because ain't nobody got time for that. This is one where it's good to do it the algebraic way because otherwise we're going to be sitting here for an hour drawing everything out. So like we said, this is independent because we put it back. We put the ball back. The total does not change. It's independent because we put the ball back and our total does not change. So our sample space here, though, if we're doing it algebraically, because we have to find the probability of each, that means that we have those numbers 1 to 15. I still need to write out all my numbers because I have to find the probability of each. That's kind of hard to see. That's better. I have to find the probability of each. So what's the first probability we're trying to find? The probability of getting a 9 And then we need the probability of a 3. Remember, we have to find the probability of each, and then what operation do we do to them? We multiply. If you need to look back, go ahead and look back. Figure out if it's independent or dependent. Calculate the probability for each, and then we're going to have to multiply them together. So looking down here, let me finish setting up my fractions. I like having everything set up so I can just plug the numbers in because that makes my life easier, I think. First, I need to figure out the probability of a 9. How many 9s are there in that box of the billiards balls? There's 1 9. Remember, the top number is what we want, what we're looking for. And the bottom number is the total. How many total balls are in that box? 15. So the probability of getting a 9 is 1 9 out of 15 total balls. Now we need to do the probability of a 3. What's the probability of a 3? It's the same. It's 1 out of 15. There's only 1 3 ball in that group of billiards. There's only 1 3 out of 15 total balls. And again, when we multiply what direction? Horizontally. So what's 1 times 1? 1. What's 15 times 15? No shame in the calculator game. 15 times 15 is going to give me 225. So my probability here is 1 out of 255. Let's turn that into a decimal. How do I turn that fraction into a decimal again? Divide it. So 1 divided by 225. Oh my goodness, 0.004 repeating. It's kind of an ugly number. How would I turn that ugly number into a percent? I could take that answer and multiply it times 100. And I would get 0.4 repeating percent, which we usually would round. Or you can move your decimal to the right 2 times and plop it in there right before the 4. You'll get the same thing. Any questions? Let us know. Otherwise, we're going to have you try one on your own. Remember the want over the total. I'm going to help you guys get this set up, but I want you guys to pull the numbers out on your own, okay? So we're still doing our box of billiards, still doing those same 15 colored balls. And we're trying to find the probability. It says you randomly draw the billiard and return it. That's going to help you think, is it independent or dependent? Find the probability of getting an 8 and then an even. Ooh. So what's the first thing I'm trying to find? The probability of an 8. And then I want to know the probability of it being even. I want to know the probability of the ball being an even number. What do I have to do with those two fractions, with those two probabilities? I have to multiply them together. So if you need this last one, go ahead and click back to it or look back at your notes to help you fill in the information. Again, I want to see the probability in a fraction, decimal, and a percent like we did on the last one. Pause the video, try this one all on your own, calculate the probability of picking an 8, putting it back, and then getting an even. All right, so this was independent because we put the ball back. If you return it, it's independent and the bottom number is going to stay the same. So we know that our bottom number is always going to be what for this type of problem? 15, because there's 15 balls. There's 15 balls. That number's not going to change. First, we're looking for the probability of an 8. There's only one 8 in a group of billiard balls. Then we were looking for even numbers. So even numbers would be 2, 4, 6, 8, 10, 12, 14. So there are 7 balls that are even numbers. So 7's going to go in my numerator. Now that I've got the probability of an 8 and the probability of an even, I can multiply across. 1 times 7 is 7. And 15 times 15 is 225. 225. So if we type that in our calculator, one way to check to see if we can simplify it, I know 7's prime. If I do 225 divided by 7, ooh, that's an ugly number. So that tells me I can't simplify by that 7. So that's in simplest form, but now I want it in decimal, so I have to divide. So 7 divided by 225, that's going to give me 0.031 repeating. That's kind of ugly. If I take that number times 100, I get my percent form. That number as a percent would be 3.1 repeating percent. And again, a lot of the times they're going to round that to the nearest hundredth. So a lot of times you'll see that rounded to 0.03 and 3% for your final answers. Most likely that's what you would see. If you have any questions on this, let us know. Otherwise, we're going to go into the next problem where we have dependent events. And you'll see what happens when we have dependent events and what that's going to mean for our total.